Hi students, welcome to Chemistry Online. In previous class we discussed construction of long form of periodic table and how many periods and how many groups are present. So in this class we are going to discuss classification of elements. Classification of elements we are going to discuss. This is a very important students, very important topic. Classification of elements. Classification of elements. Classification of elements. Classification of elements. So students, so why I am repeating 3 times means this is a very important topic. This is for 8 marks topic. This is for 8 marks topic. Classification of elements. Today we are going to discuss. How elements classified means based on differentiating electron and based on electronic configuration. So this is nothing but we are going to discuss. This classification is based on based on differentiating electron. Based on differentiating electron. Based on differentiating electron. You have to know students differentiating electron means see here hydrogen, helium, lithium, beryllium, boron, like this. Here how many electrons it having? 1, 2, 3, 4, 5. What is the difference between these two? 1. Difference between these two? 1. Difference between these two? 1. Difference between these two is 1. That is nothing but a differentiating electron. Based on differentiating electron, so the elements can be classified into 4 blocks. So based on differentiating electron, elements classified. Elements are classified into 4 blocks. Into 4 blocks. They are first one S block elements. S block elements. Second one is P block elements, and third one is D block elements. Next fourth one is F block elements. Okay students, how many blocks we have? 4 blocks. They are S block elements, P block elements, T block elements, and F block elements. So based on differentiating electron, okay, based on differentiating electron, so differentiating electron means difference between the hydrogen and helium is 1. Helium and lithium is 1. That is nothing but a differentiating electron or a valency electron. Okay. So a dummy periodic table I am going to draw. So here It is S block. Okay. Then it is D block. Then it is a P block. Then it is a S block, it is a P block, it is a D block, and it is a F block. Okay. So here IUPAC nomenclature 1, 2, like that 18. You are giving IUPAC nomenclature 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, 13, 14, 15, 16, 17, and 18. Like this we may give IUPAC numbering. So 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So 1 to 18 groups. Now we are going to discuss first S block elements. S block elements. Okay. So briefly we are going to discuss first S block, next P block, next D block. So this is S, P, D, and F. Next, first we are going to discuss about S block S block elements. Okay. See, first of all you know S block elements are placed, first you have to know differentiating electron enters into S orbital are called S block elements. Differentiating electron enters into S orbital are called S block elements. For example, hydrogen atomic number is 1. Electronic configuration is 1s1. So electron enters into S orbital. They are called S block elements. For example, lithium atomic number is 3. 1s2, 2s1. Whatever it may be S orbital, 1s, 2s, 3s, whatever it may be. If the differentiating electron enters into S orbital are called S block elements. Here that is the first point. Orbital, S orbital, differentiating electron enters into S orbital are called S block elements. The position of the S block elements. S block elements are placed left side of periodic table. Left side of the periodic table. If you stand like this, it is left side, it is a right side. So left side of the periodic table. Next, in S block, two groups are present. How many groups? Two groups are exist. Two groups are exist. First A and second A. Two groups are exist. They are first A and second A. Okay. The first A group elements are called alkali metals. Alkali metals. First A group elements are called alkali metals. Their valency shell electronic configuration is NS1. Next, second A group elements are called alkaline earth metals, alkaline earth metals, NS2. And then they are these are most reactive. Why? Because they have unpaired electrons in their valency shell. That's why these are most reactive. So these means s block elements are most electropositive. Most electropositive means they may lose electrons easily. For example, so lithium plus, magnesium plus 2. So the elements try to lose their electrons in their valency shell, they are called most electropositive. The elements try to gain electrons from to the valency shell are called electronegative. So here these are most electropositive. Okay, then these form compounds. These means these elements form compounds. So this is briefly about s block elements. So here alkali metals general electron configuration is ns1. Then alkaline earth metals general electron configuration is ns2. So only two groups means here it is first A and it is second A, like this. Okay, here ns1 electron configuration, here ns2, means we may write general electronic configuration, general electronic configuration of s block is ns122. General electronic configuration of s block is ns122. These are most electropositive, they form compounds. So most reactive, so ns1, ns2, and exist only two groups. It is left side of the periodic table. And here general electron configuration is ns122, means s orbital contains 1 electrons to 2 electrons. That is nothing but a general electronic configuration. Okay, so this is the way we may discuss about s block. So briefly, it is placed extreme. The differentiating electron enters into s orbital are called s block elements. These two groups are placed extreme, left side of the periodic table. It contains two groups. So due to presence of two groups in s orbital, two electrons can accommodate in s orbital. Due to presence of two groups in s block, two electrons can accommodate in s orbital. So these are most electropositive elements. Why? Because they always try to lose electrons, so they form compounds. Next, their general electronic configuration is ns122. General electronic configuration is ns122. This is the way we may describe s block elements. Okay, next we go for p block. One more point I have to tell, s block elements are soft metals. You have to write this. S block elements are soft metals. Okay. Next, P block. Next, P block. The same way, what is the description is going on in S block, you may convert that to P block also. So here differentiating electron enters into P orbital. Differentiating electron enters into P orbital are called P block elements. Next, so it is a left side, it is a right side, it is a right side, it is a middle, it is a left side, it is a yes, it is a left side, it is a bottom, it is a bottom of the periodic table. So now position P block is placed on right side of the periodic table. Okay, 6 groups are present. 6 groups are present in P block from 13 to 18. 13 to 18. Okay, they are 3rd A, 4th A, 5th A, 6th A, 7th A and 8th A. This is 13, 14, 15, 16, 17, 18. So how many groups are present? 6 groups. So due to presence of 6 groups in P block, 6 electrons can accommodate in P orbital. 6 electrons can accommodate in P subshell. Okay. Then, so here general electronic configuration of P block is NS2, means it having 3rd A, it is a 3rd A and it is a 8th A. It having NS2 NP1, it having NS2 NP6, NS2 NP6. So like this. So general electronic configuration of P block is NS2 NP1 to 6. That is, we may write NP1 3 electrons. So the number of electrons present in the group number indicates a group number. Number of electrons present in the group indicates its group number. NS2 NP1 to NS2 NP6. Total how many? 1, 2, 3, 4, 5, 6 groups are present. So general electronic configuration of P block is NS2 NP1 to 6. It is a P orbital and it is right side, and then so here general electron configuration is NS2 NP1 to 6. Then these are most this means 6th means 6th and 7th. 6th A, 7th A are most electronegative elements. 6th and 7th A are most electronegative elements. Next, 8th A are inactive elements. Inactive elements due to ns2 np6 electronic configuration. So next remaining 1 2 means third A to 7th A group elements are most reactive, but 8th A elements are inactive elements. Why? Because they have ns2 np6 stable electronic configuration. Okay, in p block metals comma non-metals and metalloids are present. So metals means having metallic nature, non-metals means having non-metallic nature, metalloids means 50% metallic nature and 50% non-metallic nature. Both in p block metals and non-metals and metalloids elements are present. Okay, and then here these are also most reactive elements. They are nothing but electronegative, so are inactive elements ns2 np6. Next we may write so p block elements and s and p block elements are called representative elements. Representative means main important elements. So this is the way. So here third A, fourth A, fifth A, sixth A, fourth A, fifth A, sixth A and seventh A are most reactive due to presence of unpaired electrons. So this is briefly about p block. This is briefly about p block. How many blocks? 1 2 3 4 5 and 6. Okay, next we are going to discuss about d block. So here you have to know about p block. P block differentiating electron enters into p orbital are called p block elements. Then they are placed on right side of the periodic table. 6 groups are present, 13 to 18, here to here. Then third A to 8th A. Then general electron configuration of p block is ns2 np1 to 6. So 4th A, 7th A are most electronegative elements. So 8th A are inactive elements. In p block metals and non-metals and metalloids are present. So 3rd A, 4th A, 5th A, 6th A and 7th A are most reactive. They can form compounds like S block elements. Okay, then we are going to discuss about d block. We are going to discuss about d block. Okay, it is a d block. It is a d block. D block elements. So differentiating electron enters into d orbital. Differentiating electron enters into d orbital are called d block elements. Okay, they are placed in between the s and p block elements. Placed in between s and p block elements. Okay, they are act as bridge elements to the S and P block. Okay, how many groups are present? 3 to 12 means 10 groups are present. 10 groups are present from 3 to 12. 10 groups are present. So this is third A and so on, it is a second A. Okay, they are third B, third B, it is nothing but a B groups, it is nothing but a B group, third B, next fourth B, fifth B, sixth B, seventh B, eighth B can be divided into 3 groups, next first B and second B. Okay, 1 2 3 4 5 6 7 8 9 10. How many groups? 10 groups are present. These are called transition elements. Transition elements. Why these are called transition elements means due to presence of unpaired electrons in d orbital. Due to presence of unpaired electrons in d orbital. Here general electronic configuration of d block, okay, it is n minus 1 d 1 to 10 ns 1 to 2. Here it is ultimate shell, it is a penultimate shell, both are partially filled, that's why these are called transition elements. That's why these are called transition elements. It is a transition elements. Next, they are hard metals. They are hard metals. Okay, this is you have to know, hard metals. Next, they are in 4 series. 3D, it is a 3D, 4D, 5D, 6D. They are in 3 series. See, due to presence of unpaired electrons, they form some typical properties. Means they form colored compounds, they form colored ions. Next, they form complex compounds, Next, they show variable oxidation states. Variable oxidation states. Variable oxidation states, they show magnetic properties. They show magnetic properties. Okay, these are typical properties of D block elements. Why D block elements having typical properties means due to presence of unpaired electrons, means a single electrons in D subshell, D orbital. Okay, so these are nothing but they form colored ions, they form complex compounds, they show variable oxidation states. Variable oxidation states means more than one. If the atom show one oxidation state, then if the atom show more than one oxidation state, then that is nothing but a variable oxidation states. What are oxidation states means we are going to discuss. Just you know typical properties. Okay, these are. This is briefly about D block elements. So what are D block elements means? The elements, the electron, the differentiating electron enters into D orbital are called D block elements. So this is the way. It is in between S and P block elements. Here it is in between S and P block elements. So it is how many groups? 10 groups like this. 10 groups are present. So in between. Next, these are called transition elements. Why these are called transition elements means due to presence of unpaired electrons. Except this group, except second B group. Okay. So this is briefly SPD blocks. In tomorrow's class we are going to discuss F block. Okay.